Welcome back, everyone. We're going to now be going over Chapter 6 in the Foundations book for Chemistry and Chemical Safety. Our learning objectives are explain chemistry and chemical safety, identify the basics of chemical structure, explain the difference between solutions, suspensions, and emulsions, describe potential hydrogen and how the pH scale works, summarize neutralization and redox reactions, practice chemical safety, and interpret safety data sheets. Chemistry is everywhere, so it makes up everything that we know, everything that we love, and it is what makes life possible. Our body's functioning is based off chemical reactions, and we are all made up of chemicals. Even the creams and lotions and masks, any skincare product that we use is either made up of natural sources like plant extracts or ingredients that are manufactured in labs. And whether they're natural or man-made, all of the ingredients are made of chemicals. The effects of the products that we use, so the cosmetic products that we use, are based on how the body reacts to chemicals. We should have a basic knowledge of chemistry just to understand how different chemicals affect the skin and how to be able to choose the correct products for each client's individual needs. Chemistry is the science that deals with the composition, structures, and properties of matter and how matter changes under different conditions. And matter itself is a substance that occupies space and has mass or weight. So since matter is made up from chemicals, everything made out of matter is a chemical. And everything that is known to ever exist in the universe is made up of either matter or energy, and there is no exception to this rule. And so if something's not matter, it's energy, and energy is something that does not occupy space or has mass. An element is the simplest form of chemical matter, so it cannot be broken down into any simpler substance without a loss of identity. So all matter in the universe is made up of elements, and they have their own distinct physical properties and chemical properties. Each element is identified by a letter symbol, so if you see the periodic table, you would see O, which stands for oxygen, H is for hydrogen, N is for nitrogen, S is for sulfur. So all of those, oxygen, hydrogen, nitrogen, sulfur, all of those are elements. And there are 118 known elements, and 98 of them are naturally occurring. In each element, we have atoms, which are the basic unit of matter, and they consist of a nucleus in the center, and they are surrounded by electrons, so negatively charged electrons that move around the nucleus. And they also consist of, inside the nucleus, has protons, which are subatomic particles, which are just very, very, very tiny particles that have a positive charge, and neutrons, which are also very, very tiny particles that have no charge or are neutral. The number of protons, so those positive charged particles, are what determines the element. So the number of protons an atom has is the element that correlates to the number on the periodic table. And since atoms are the very basic unit of matter, they cannot be divided into simpler substance by any ordinary chemical means. A molecule is a chemical combination of two or more atoms in a definite or fixed proportion. So, for example, water is made up of hydrogen and oxygen. And to make water, or H2O, you always need to have 2 hydrogen and 1 oxygen. So that is a fixed proportion of elements to make the molecule. An elemental molecule is a chemical combination of atoms of the same elements in fixed proportions. So the air that we breathe is an elemental molecule of O2, and the ozone in the atmosphere is an elemental molecule of O3. So the air that we breathe, so the oxygen that we breathe and the ozone are only made up of oxygen, but it's just the number of molecules that they have, which makes them different. Compound molecules are chemical compounds of two or more atoms of different elements in fixed proportions as well. So sodium chloride is NaCl, so sodium and chloride molecule, which is just common table salt, and that's a compound molecule that contains one atom of sodium and one atom of chlorine. If the sodium had two molecules, it would no longer be sodium chloride, it would no longer be table salt, and vice versa. If the chlorine had more than one molecule with the one sodium, it would no longer be table salt, it would be a completely different molecule. Physical properties of things are characteristics that can be determined without a chemical reaction, and they do not involve a chemical change in the substance. So this would be properties like a color of something, the solubility, so if it mixes in with water, the odor, the density, melting point, boiling point, or the hardness of something. While chemical properties are characteristics that can be determined only from a chemical reaction and a chemical change in the substance. So this includes the ability of iron to turn to rust, or wood to burn, or hair to change color through the process of using hair color and hydrogen peroxide. A pure substance is a chemical combination of matter in a definite or fixed proportion. So again, H2O being water, that's an example of a pure substance. There's always going to be two hydrogen atoms per one oxygen atom to make up H2O or water. Any differing amount of oxygen with the two hydrogens would be a completely different substance, and it would no longer be water. And also table salt, so sodium chloride, one sodium atom per one chlorine atom makes up the NaCl or table salt. And again, any differing amounts of atoms, like an extra chlorine atom per one sodium atom, would be a completely different substance, and it would no longer be salt. Physical mixtures, on the other hand, are a physical combination of matter in any proportion. So the properties of a physical mixture are the combined properties of the substances in the mixture. So salt water would be a physical mixture of salt and water in any proportion. Also, beauty products that we use would also be physical mixtures. Our first question is, what is an example of a chemical change and a physical change in the skin with products that we may use? And I will give you an example that you can use with exfoliants, so keep that in mind. You can use them for both, so if you can give me an example of what you could use for both, for exfoliating, a chemical change and a physical change in the skin. Solutions, suspension, and emulsions are all physical mixtures. A solution is a stable, uniform mixture of two or more substances in a solvent. A solute is a dissolved substance in the solution, and the solvent is the substance, which is usually a liquid, that dissolves the other substance to form a solution with no change to the chemical composition, and water is the most universal solvent. So if we use our previous example of salt water, the solvent would be water and the solute would be the salt, and combined it would make a solution of the salt water. Miscible liquids are mutually soluble, so they can be mixed together to form solutions. Water and alcohol are miscible because when they're mixed together, they stayed mixed together and they form a solution. The way I remember miscible liquid or miscible substances is miscible sounds like mixable, so I know that they are easily mixed. While immiscible liquids are not mixable, so they do not mix together cohesively, and they are not capable of being mixed to form a stable solution. So an example would be oil and water. If you've ever done that little science experiment where the oil will sit on top of the water, those are immiscible substances. Suspensions are unstable physical mixtures of undissolved particles in a liquid. So oil could be suspended in water to make a suspension. An emulsion is an unstable physical mixture of two or more immiscible substances. So again, the substances that normally don't stay mixed together, plus a special ingredient called an emulsifier. An emulsifier is an ingredient that brings two normally incompatible materials together and binds them into a uniform and stable mixture. So emulsions are typically a type of suspension because they can separate, but the separation process happens very slowly or over a long period of time. So this would be in our cream products that have water at the top of the ingredient list, but there's also other oils in it. Normally those things wouldn't mix well together, but since they have an emulsifier in them, they mix well together. Also, we can see this happen, the emulsifying action happen when we use our cleansing oil. So once it's on dry, it's just an oil, we use it, and then once we add water to it, it turns kind of milky, and that's how we know there's an emulsifier that has been used in it to make the oil and the water combine a little bit easier, which just makes it easier to come off the skin, or those oils come off the skin. Surfactants are substances that allow oil and water to mix or emulsify together, and they're just one type of emulsifier. The term surfactant is a contraction for surface active agents or substances that allow oil and water to mix or emulsify. So there's hydrophilic heads that are water loving, and those are the ones that dissolve in water, and lipophilic tails, which are oil loving, and those dissolve in oil. We have two types of emulsions. We have oil and water emulsions, or OW emulsions, and these are emulsions that have tiny oil droplets that are emulsified into water. The droplets of the oil are surrounded by surfactant molecules, with the lipophilic tails pointed in towards the oil, and the hydrophilic heads are pointing outwards towards the water. The tiny oil droplets form the internal portion of each oil and water emulsion because the oil is completely surrounded by the water. These aren't going to feel as greasy as water and oil emulsions because the oil is hidden and the water forms the external portion of the emulsion. So these would be more lighter weight emulsions. Water in oil emulsions are having our water droplets that are emulsified into the oil. So the droplets of water are surrounded by surfactants, again, with the hydrophilic heads pointing in towards the water and the lipophilic tails pointing outwards towards the oil. The tiny droplets of water form the internal portion of the water and oil emulsion because the water is completely surrounded by the oil. And these are going to feel a little bit more greasy than oil and water emulsions because the water is hidden this time, and the oil forms the external portion of the emulsion. So this is going to be more of our balmier products. Some other examples of physical mixtures would be ointments. So ointments, paste, pomades, and waxes are semi-solid mixtures made up of any combination of petroleum or petroleum jelly, oil, and wax. Powders are also physical mixtures of one or more types of solids. So these would make up our blushes, bronzers, highlights, or powdered foundations. Or for an example of a product that we might use, enzyme therapy, that's a powdered mixture of two or more physical solid substances. Some common chemical product ingredients that you may come across are volatile alcohols, which evaporate easily. This would be our isopropyl alcohol or rubbing alcohol, and our ethyl alcohol you may see, which is in hairspray or some beverages. Our alkanolamines are alkaline substances that are used to neutralize acids or raise the pH of products, like baking soda, and these are typically used in place of ammonia. Ammonia is colorless and it has a very pungent smell, so it really stinks, and it's composed of nitrogen and hydrogen, and in a water solution it's called ammonia water. And it's also used to raise the pH or potential hydrogen in products, and it's typically more used in hair products like perms, hair coloring, and lightening substances. And it just raises the pH to soften and swell the cuticle, which just allows solution to penetrate into the hair shaft. Glycerin is a sweet, colorless, oily substance, and it's used as a solvent or as a moisturizer. It's very hydrating. It's also a humectant, which just draws water towards the skin. Silicone is a special type of oil used in hair conditioners, water-resistant lubricants for the skin, and some face primers. They are typically less greasy than other oils and can have a slightly silky, smooth feel to the skin, or give shine to the hair and make the hair a little bit softer. And they can help also smooth the face for makeup application. Volatile organic compounds are just compounds that contain carbon, which means they are organic, and they evaporate very easily, which means they are volatile. And the most common used is going to be our ethyl alcohol. Overexposure refers to how prolonged, repeated, or long-term exposure of certain chemical products or product ingredients can cause sensitivity in some people. The overexposure principle is used to describe how overexposure determines the toxicity. So it's remembered to know that the dose of something is what determines whether it will have a negative or poisonous effect on the body. So for an example, salt water, it's very toxic to drink, but it's safe to swim in. So the ocean, being salt water, you can swim in it, but it's better to not drink that water. Our second question is, what are solutions, solutes, and solvents? Potential hydrogen is abbreviated pH, and it's written with a small p, which represents the quantity, and a capital H, which represents the hydrogen ion. So pH just stands for the quantity of hydrogen ions, which is the potential hydrogen then. An ion is an atom or molecule that carries an electrical charge, either positive or negative. An ionization is the separation of an atom or molecule into a positive or negative ion. An anion is an ion with a negative electrical charge, and a cation is an ion with a negative electrical charge. So we'll have to remember these ones specifically. Anion versus cation, which one is negative, which one is positive. In pure water, some water molecules will naturally ionize into hydrogen ions, and some will be into hydroxide ions. The hydrogen ions are going to be what are acidic. So hydrogen ions being H positive are acidic, and hydroxide ions, which are OH negative, are alkaline. So if something has more hydrogen ions, it's going to be more acidic. If something has more hydroxide ions, it's going to be more alkaline. Also good to know, only aqueous solutions, so water solutions, have pH. So non-aqueous solutions like oil or alcohol do not have a pH. So without water, there is no pH. Only pure water contains the same number of hydrogen ions as hydroxide ions. So distilled water is going to be our neutral pH because it has the same amount of both hydrogen ions and hydroxide ions. The pH scale measures the acidity and the alkalinity of a substance. It's a scale that ranges from 0 to 14, where 7 indicates the neutral solution, which would again be our distilled water because again it has the same amount of hydrogen ions as it does the hydroxide ions. Below 7 indicates acidic solution, and above 7 indicates an alkaline solution. Also good to remember that our skin naturally is between a 4.5 to 5.5, so an average of 5 on the pH scale. So that would mean it's slightly acidic. The pH scale's logarithm is in multiples of 10. So the pH of 6 is going to be 10 times less than the pH of 5, and the pH of 5 is going to be 10 times less acidic than the pH of 4, and then going on and going so forth. So to jump a couple numbers, so from 4 to 6, it's going to be 100 times more acidic at pH 4 than it is at pH 6, if that makes sense. All acids owe their chemical reactivity to the hydrogen ion, so remember the hydrogen ion being just H+. All acids have a pH below 7. Some acids that we may come in contact with would be alpha hydroxy acids. So these are derived from plants, mostly fruit, and are examples of acids often used in treatments to exfoliate the skin and help adjust the pH of a lotion, conditioner, or cream, being like citric acid you'll see a lot of the times on product ingredient lists. Thioglycolic acid is also a colorless liquid or white crystals with a strong unpleasant odor that's typically more used in perms to contract and close the hair cuticle after the ammonia compound was on top of the hair. Glycolic acid is an alpha hydroxy acid that is used to exfoliate and lower the pH of products as well. Alkalis or bases mean the same thing. These owe their chemical reactivity to the hydroxide ion or the OH negative ion. The pH of these are going to be above 7, and they typically have a feeling like a slippery or soapy feel on the skin. So if you've ever used OxyClean or touched OxyClean and then like went and washed your hands off a little bit, sometimes it has like a very soapy, slippery feel on the skin. Sodium hydroxide or lye is used in chemical hair relaxers, callus softeners, and drain cleaners, and they're also in the bar soaping making process. Our third question is, why is understanding pH important for the skin? In the acid-alkali neutralization reaction, it's the same reaction that naturally ionizes water into hydrogen ions and hydroxide ions, run in reverse. So when acids and alkalines are mixed together in equal proportions, they neutralize each other to form water. So if you mixed vinegar and baking soda together, there would be a chemical reaction that makes a gas but also water. Vinegar being the acidic part and then baking soda being the alkaline part. The biggest example that we will use for this in our class would be chemical peels. So we use chemical peels, which is going to be a more acidic solution, and we neutralize the solution after it's sat on the skin for a while with softening gel, which would be an alkaline product to neutralize the chemical peel that it's after it's been on long enough. Oxidation is a chemical reaction that combines a substance with oxygen and produces an oxide. In a oxidation reaction, there is an oxidizing agent, which is a substance that releases the oxygen. In a reduction reaction, it refers to either the loss of an oxygen or the addition of hydrogen. And a reducing agent is a substance that adds the hydrogen to a chemical compound or subtracts the oxygen from the compound. And there is something also called a oxidation reduction or redox reaction that combines the oxidation and reduction reaction together. And it's a chemical reaction which the oxidation and reduction reactions take place at the same time. So the oxidizing agent is reduced by losing an oxygen, and the reducing agent is oxidized by gaining an oxygen. So both reactions are happening at the same time, causing an oxidation reduction reaction. An exothermic reaction is a chemical reaction where heat is released. So an example of this would be when hard wax is laid. The wax going on is soft, and while it is hardening, an exothermic reaction is taking place because it is hardening and it is becoming cooler. Combustion is the rapid oxidation of a substance accompanied by the production of heat and light. And an endothermic reaction is a chemical reaction that requires the absorption of energy or heat from an external source for the reaction to occur. So this would be like applying a cooling gel or cooling mask or aloe vera, because once it's applied to the skin, it cools the skin physically due to the water content, but it can also absorb the heat from the skin, producing a cooling sensation. So products that have a menthol in it or like a cooling sensation, like biofreeze, if you've heard of that, is causing an endothermic reaction. Our question 4 is, what are neutralization reactions and why are they an important part of the skincare services that we may do? Practicing chemical safety should be a primary concern for us. From transporting to disposing of chemicals, we need to be aware of the risk involved in the process needed to ensure our safety and other safeties. Reading the labels on products that we use and making sure that we're using them correctly and understanding how to safely handle them is very important, especially with our disinfectants and stuff like that. Manufacturers of chemicals that are registered with either the EPA or FDA are held at a stricter standard for their labels, so they require all hazards to be disclosed alongside specific cautions and directions for the use of them. We also need to make sure we follow all label instructions to avoid dangerous and painful situations. Some products may have warnings that affect how you transport them. Maybe some say don't store them in temperatures of 78 degrees Fahrenheit or higher, or avoid direct sunlight. It's good to know how it's not safe to transport products in certain conditions, or keeping them in certain areas for storage, like your garage or your car on hot summer days and things like that. Products that are incompatible should not be mixed or even stored near each other. So for example, ammonia and bleach should definitely not be anywhere near each other. And all chemicals should be transported upright and in their original containers. And partially used containers should not be transported at all. For product storage, there should be a designed place to store specific chemicals, and you should never allow chemicals to sit out, even in a dispensing area. Chemicals should be locked up at all times, and if an adult can get to them, so can a child. Hopefully there's no children in our classroom, so we shouldn't have to worry about that too much. And all chemicals should be stored and disposed of in their original containers. And even if two chemicals are similar, they should never be hazardly combined together, stored, or mixed. And when storing chemicals next to each other, it's critical to know how the two would react if they somehow came in contact with each other. So some mixing guidelines: the location you use for mixing chemicals must be well ventilated and have protective equipment available, including an eye wash bottle. Chemical labels should always be read thoroughly prior to mixing, and if there are any potential reactions listed and you're uncertain if the chemicals should be mixed, you should not mix them at all. Using a measuring device and making sure that it is cleaned thoroughly between uses. Always adding chemical to the water and not the other way around when using concentrated chemicals like disinfectants. And when using concentrates that are mixed and used in a secondary container, like a spray bottle, that container should always be labeled to indicate the product name, ingredients, and any hazards listed by the manufacturer. For disposal of chemicals, many of the chemicals that go down the sink every day are dangerous to the environment and can create burdens on our water systems. And in many parts of the country, programs that recycle the chemical waste from beauty services exist and will likely continue to grow. OSHA requires that employees be notified of any chemical in their workplace that could be hazardous. And prior to 2005, there was something called Material Safety Data Sheets, or MSDS, which was the document used to provide information to workers and first responders. But in 2015, these were replaced by the safety data sheets that we know today, so the SDS, which just improved the organization and ease of understanding. All safety data sheets are formatted into 16 categories with 9 accepted pictograms and are provided for free from the manufacturer of the chemical used. Having safety data sheets available for every chemical used in the salon is a requirement for OSHA, and additionally, it's required that all safety data sheets be immediately available to all employees, so storing them on a computer that only managers can access or keeping them in a locked office cabinet is not acceptable. For the safety data sheet categories, there is number 1, identification, which includes the name of the product and contact information for the manufacturer or distributor, and it also contains recommended use and restrictions on the use. Hazards identification lists all hazards associated with the product and includes hazard classification like flammable, precautionary statements, and hazard pictograms as well. Composition and information on ingredients identifies the ingredients of the product, including concentrations used in mixtures and when chemicals have been withheld due to a trade secret. First aid measures include short and long-term symptoms and first aid instructions. Firefighting measures lists suitable and unsuitable, technically, fire extinguishers and any chemical hazards associated with a fire, and recommend protective equipment or precautions. Accidental release measures provides instructions for proper cleanup of a spill, protective equipment needed, and emergency measures to follow. Handling and storage includes the guidelines for safe handling and storage of the chemicals and includes the incompatible chemicals. Exposure controls and personal protection provides recommended limits on exposure and methods to reduce exposure, such as personal protective equipment and proper ventilation. Physical and chemical properties will consist of a minimum of 18 properties, from the color to pH or viscosity of products, and unknown or irrelevant properties for a product have to be noted. Stability and reactivity provides information on the environmental stability and reaction risk associated with the product. Toxicological information details the risk of exposure, including symptoms like skin irritation and measures of the toxicity of substances. Ecological information covers the impact of the chemical on the environment, such as groundwater absorption or danger to plants and animals. Disposal consideration lists any procedures for disposal. Transport information provides guidelines and restrictions for safe transportation. Regulatory information will include any specific safety, health, or environmental regulations. And other information will just indicate when the SDS or safety data sheets were created or last updated. Some safety data sheet vocabulary that we might want to know is carcinogen. So a carcinogen is a substance that causes or is believed to cause cancer. A mutagen is a substance that may cause cancer, but not always. Mutagens can cause an increase in cellular mutations or changes, and some of which are harmful, and others have little to no effect on the body's function. Combustible material is capable of igniting or burning. Flammable material is even easier to ignite, so combustible liquid has a flash point between 100 and 200 degrees Fahrenheit, while flammable liquid has a flash point below 100 degrees, so a lot easier to ignite. And the term inflammable is an older term meaning the same thing as flammable, and non-flammable is used for something that is not flammable. So a reminder of what our learning objectives were. We explained chemistry and chemical safety, identified the basics of chemical structure, explained the differences between solutions, suspensions, and emulsions, and described potential hydrogen and how the pH scale works. We also summarized neutralization and redox reactions, practiced chemical safety, and interpreted safety data sheets. And that will conclude our Chapter 6 in the Foundations book for chemistry and chemical safety.